And I'm gonna grab beer because it's 6 o'clock. And by beer, today I mean nice Japanese whiskey from Tenjaku. I'll just go right into this big bug. So here's how the story starts. So I'm reviewing a smart contract, and here's what a review from Will looks like. Piles of issues and just all kinds of discussion. And so they had come back with a lot of updates on this. If you're an Arbitrum or Bridgeworld fan, shout outs. So we're going through this together, great process. Part of the review is I start going back. So I want to see what's changed, see if my notes are still make sense or, their craziness. I got down to this one. Solidity version is not supported. This is a common finding when you're auditing, is you want to make sure you're using the latest version of Solidity. How do I know what the latest version is? Well, I go to Solidity documentation and I pull up Solidity. Solidity is the smart contract language that we use for Ethereum, usually. There's also Viper, and you can do it with Yule. You can do it some other ways too. So what you do is you come here and you go on GitHub Solidity and you look at releases on the right. This is what I normally do. You just come here, you make sure this is a new release, and this one came out yesterday, and I was looking at it yesterday, so it's like great timing. So I read this. You always want to read the bug fixes. A bug fix can mean the compiler output the wrong thing. Maybe it's, the error message is wrong. Maybe the compiler is slow. That's a bug fix. This is a really good bug fix. This is one where the result smart contract that is compiled is wrong. And here's how that's explained. Code generation. Fixed data corruption. Ooh, that already sounds bad. Code generation and data corruption. That's already okay. Get my glasses on. That affected ABI encoding of call data values represented by tuples, structs at any nesting level, argument lists of external functions, events and errors, return value lists of external functions. The 32 leading bytes of the first dynamically encoded value in the tuple will get zeroed when the last component contained a statically encoded array. All right. So these are super important words, every one of them. So we're gonna save that. So something's wrong, 32 bytes, something zeroed. Zeroed. That sounds like data corruption to me. So something is zeroed. Okay. Obviously, there's going to be a write-up about that. So let's click the release announcement. So you've got the release is yesterday on the 8th. The announcement is yesterday on the 8th. And then there's a blog post also on the 8th. This is what I call a coordinated release schedule, where the bug, the release, the announcement is all scheduled at the same exact time. So that's like a Patch Tuesday right there. Patch Monday? It's Tuesday somewhere. When you see such coordination on the blog post, the release, the deployment of the release, like that's something that indicates that something was done behind the scenes that you're not seeing about. So I'm going to guess that this is a bug that was reported through the security mailing list that, is not public. Now you got the blog post. Yeah, we're gonna do that. Can we use regex to find these examples of these problems and then look for exploits? And you don't have to look across all of GitHub. I mean, we could. And the regexes are not that powerful for this. But we're going to try. And I've tried a regex, so you got to do this manually. Here's the release announcement. Here's the bug description. And here's the blog post. Pictures, examples, code, test. Like you can tell this is important. All right. So affected is compiler version 0.5.8 up to 0.8.15. That's a big range. We assigned the bug a severity of medium. Medium is serious. We're using probably OWASP. An OWASP medium security, that's a serious problem. Uh-oh. What contracts are affected? So now we got to read this. We got to parse this. The last component of the tuple, the effects of this bug manifest when a contract performs ABI encoding of a tuple. Part 1, ABI encoding of a tuple that meets all these conditions. The last component of the tuple is a potentially nested static size call data array, with the most basic type being either uint or bytes 32. Okay? The tuple contains at least one dynamic component. The code is using ABI encoder v2, which is the default from 0.8. ABI encoder v2 gives you some extra features, specifically regarding tuples, and some people turn this on. Structs are represented as tuples in the ABI. Parameters and return lists of external functions, events, and errors are implicitly treated as tuples. So parameters, these are important. When you have a function, the parameter is the input. So if we can mess with the input, that's a big deal. Messing with the return value might be a big deal if it's dependent on from a smart contract. Events and errors, they don't matter. Events don't matter. Can we mess with an event or error? That really doesn't matter because these are going to be passed through some type of a DAP anyway. and they're probably going to get handled by some system that you can upgrade, as opposed to a smart contract, which hopefully you can't upgrade. The bug can be triggered by explicit use of API encode. Nobody's going to use that. As well as the API coding performed implicitly for external functions. Okay? So now there's the third part. There's going to be an external function call. The bug is independent of the optimizer, affects the normal code. We've got our notes here. Let's find an example, see if we can exploit the example, make a minimum test case, and then go find if there's a specific, extremely high value billion-dollar contract out there that we can exploit, one that we can investigate. Really, this is good notes. So this is great to have a write-up here. And these technical details explain what's broken, how it got broken, why it got broken, what the impact is. Honestly, I would have moved that stuff lower if I were writing this, because you don't need to know why it's broken. You just need to know what's broken, and it takes a while to get to that. Here's an example that's not a problem. Here's how it's supposed to work. Here's an example. They use ASCII art too, just like me. Here's an example that is broken. Here's the how it should work or doesn't work. Here's the ASCII art there. Let's try this. Solidity API bug, blank. All right, let's try that. New workspace. Let's try to run this. Run it locally. London, local account, deploy. Okay, so we're going to run something with a bool, a tuple, and a C. The bool is going to be true. The tuple is going to be, let's do false. You know, it's really hard to fill in these darn arrays in Remix and Etherscan, so there's some magic here you just got to know. So the tuple is going to be a bytes. It's going to be this bytes here. So that would be like OX 1, 2, 3, 4 maybe. And then there's going to be a Y, which is a uint3, which is going to be like a 1, 2, 3. And there's going to be a C here, which is a bytes 32. There's two of those. So then there's going to be an array here of bytes 32. I don't know if this is going to work. We're going to try OX01 and OX02. It's probably not going to work. Incorrect data length. Okay. 01. Okay, so we might need to have 32 actual bytes here. Okay, that worked. Well, that transacted. So what happened? There's a return value. So it's basically taking an input of A, B, C, and it's returning an output of A, B, C. So it's supposed to pass whatever comes in. The input here was false. We got a false. The B was an input of a tuple of 1, 2, 3, 4, and then these numbers 1 and 2 and 3. And the output was a tuple of 0x, which looks wrong, and then a 1, a 2, and a 3. And the input was this 1, 2, 3, 4 thing, and a 1, 2, 3, 4 thing. And the output is a 1, 2, 3, 4 thing, and a 1, 2, 3, 4 thing. Cool. Okay, now let's try the zinger. True. Okay, the input is true, OX 1, 2, 3, 4, 1, 2, 3, C. And the output is true, OX 1, 2, 3, and these two things. Huh. So it looks like maybe this OX thing is wrong. It looks like maybe the value should be here, the actual bytes inside there. Like this thing might not be getting passed in the output. It looks like that's the problem. I thought that true was going to get overwritten too. Maybe I misread that. There's a tuple, there's a struct, it's in the call data. The call data has a dynamic thing with bytes, and then there's a call data here with a array, but it's a fixed length of 2. This is cool, but this is not like minimal yet. We got to turn this into a minimal test case that's just going to fail. There's a lot going on here. Like, is this bool necessary here at the front? Can I actually take this test case and then make a test? So it's cool if you can make a test case in Solidity. I guess we can make a test function. So function test. First, we're going to deploy the contract E. So this is going to be, I guess E stands for error. E equals new E. And I have to have some inputs. So we're going to have some test inputs. So we're going to have a bool test A equals true. T test B equals T of some bytes. We need some bytes. So we got a OX 1, 2, 3, 4, static array of 3 things, 1, 2, 3. And then we need to test C. So, oh, that didn't work. Memory, call data, test, call data test. Okay. And then we have to have the item 3 bytes 32 to call data C equals this. All right. So it equals that. Now we're going to do the test case. So we got the test inputs, test A, test B, test C. Then we got this new contract E. Then we've got the result A, result B, result C equals F of test A, test B, test C. And now we need to do some assertions here. Require that result A equals test A, or else test A fail. Why doesn't this one run? I need a storage location here. Invalid type for argument in function list. Invalid complicit inversion from bytes memory to uint8 memory to uint256. Okay, explicitly cast. Type struct T memory is not implicitly convertible to call data. Okay, so we need memory. Type string memory to memory. Type string memory to memory is not implicitly convertible to type bytes 32 memory. What? Type string memory to. Why is this string memory to? Okay, that's a little verbose. Gotta cast that 3 times. Type struct T memory is not convertible to struct T call data. Okay, so this needs to be memory. Now we're gonna test B. B is this type T, which has an X and a Y. So we need to test result B.X equals test B.X, B.Y equals test B.Y. Operator equals not compatible with types byte memory and bytes memory. So you have to use a trick to compare strings. Okay, so we've compared these. Now we gotta compare C. And C has 2 parts. So there's gonna be a C0, 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 and a C1. Okay, this looks like a test case. And let's runner. Compile. Auto-compile. Good. Test. Deploy. Deployed. Okay. Test. Failed. Okay. Test failed on B.X. B.X failed. And B.X is this byte's value here. So this is exactly the thing that we had. When we saw it before, we saw the log before, the output was 0.x, or we were expecting 0.x 1, 2, 3. Okay, so here's a test case, but is it minimal? So now we want to go through a few rounds here of creatively looking at ways that we can reduce this test case. Is there anything that we can remove from this test case and still have it fail? Let's see if we can remove the bool argument at the beginning. So remove the A here, the returning the A, the test A, comparison. So now we've got a smaller test case. Let's see if this also fails. Test, deploy, test, run, failed. B.X failed. Okay, good. So we've done something productive here. So far, what we've done is we've just taken the bug and we've got a better bug. If a bug has a lot of steps, that's bad. If the bug has 1 step, that's worse. And that's what we've done. Also, let's just check the regression here. Let's try this on Solidity 16. And let's deploy that. Test, test, pass, green. And then we go again to 15, save, test, test, red, fail. Okay. We got a test that failed on 15 and passed on 16. Can we reduce it further? This is dumb, but can we take the size of the array and make it 0? Can we have an empty array here for the second argument? I don't know. Let's try it. 0. So we're going to have an empty array. Array with 0 length specified. Can't do that. Can we do it with 1? One of these. Wow, it even knows that. That's out of bounds array access. Well, that's nice static code analysis. Thank you. Let's try it. Deploy, test, test, fail. Let's do it in 16. Deploy, test, test, pass. Okay, that's an improvement. Let's keep it going. We've got 3 elements of this Y array. Let's try 1. Test, test, passed. Wait, did it fail last time? 15, deploy. Deployed successful. Test was successful. Oh. So if there's only 1 element in that last array, the test was successful. Let's just try changing the variables a little bit. So 7, 7, 7, 7. Let's put a 3 here and a 16 there. Let's deploy the test. And it failed. Maybe there's a specific number I was using. I don't know. Now we'll try it in 16. Deploy, test, test, pass. Okay. So we've minified it more. We've got a test now that, and there's some reason there's this compiler warning, which doesn't make sense. Why it would matter if there's 1 or 2. Okay. Does that have to be public? Can this be external? Does that matter? Deploy, test, test, failed. Try it in 16. deploy, test, failed. That's weird. Okay, let's review. Bytes X, Y, we've got a B and a C here. We've got a B, a C, we've got a single element here. The B is tested, the BX, the B is tested, the BY, the first element. The C is tested, which is the 16 in an array. And the B.X is failing. Okay, well, if we just found a bug in the latest version of this compiler, that'll be scary. Okay, so whatever it was, maybe there's a different bug, but that's not what we're looking for today. So let's keep it as public. Deploy, fail, B.X fail, deploy, test, pass. Okay, what else can we try? So here's the latest failing test case. How can we make this smaller? Let's review also, maybe there's a hint with the known bug. The last component of the tuple is a potentially nested static sized call data array, with the most base type being either uint or bytes 32, like a bytes 3210 or a uint 2. I guess if it's an array with a length 1, it's treating it as a literal. So this is actually wrong. It needs to be with a length greater than 1. The last component of the tuple is a statically sized call data array based on a bytes 32. Okay? The tuple, so I think here the tuple means these function parameters, like the pair of there's two parameters, so t call data b and bytes 32 1 call data c. So these two things. The tuple contains at least one dynamic component or a struct containing a dynamic array. So wouldn't this be easier if I just put the bytes here?
Right.
So instead of having all this stuff, let's just have bytes call data b, and then the result will be bytes call data. I have a feeling that this public and this call data is significant for the 16 version. Okay, bytes call data b, bytes call data returns bc, and then here, instead of the test b being test b memory, it's going to be bytes memory test b equals, whose name's first? Dan's on the mic. Dan. All right, so this is our new test b. Then the result here is going to be bytes memory result b, and then we're going to compare not result b.x, but just result b to test b. And then there is no result b.y. Okay, that's a thing. Delete, test, deploy test, run test in 15, fails, good, or cool. 16, delete, deploy, test, pass. Okay, so we've just majorly minified this test case a lot. We removed a whole...
This is so much broader.
Yeah, it's getting better and better as we like muck with it. It used to have like all these components, and now it's like, you know, much more broad. Okay, so all we have here is two things. We have a call data B, and then we have this array here. And let's just go make a quick...
What are the reasons designers of the language would want or not want the ability to create zero-length arrays?
When you're designing something, you're trying to make something useful.
Not much you can do with it.
Whoever typed this shit into that box, like, what idiot would ever want to do this? Exactly. People messing around that have nothing better to do than create zero-length arrays to try to find bugs in your compiler. If I switch it to external, is this still a valid bug report? Test, broken, 16, test, good. Okay, so for some reason, putting external here is a valid, it isolates on 15, passes on 16, fails on 15.
What about using fixed size byte arrays that are smaller?
See, instead of 32 using like this, yeah, oh, bytes 1, yep. See, bytes 1, bytes 1, bytes 1, uint 8, and the value that fits is 16, because that's 42 is customary. The number used to be 69 in all the documentation. For everything Solidity was 69, all the test cases. Okay, so let's try it in 15. Deploy, test, huh.
Oh, and the error message should just be test B.
Say again?
The error message is
Here.
Has to be
Yeah.
not .x.
So for some reason, this is passing.
I guess it has to do with length of the byte array, right?
Right. So the thing that's getting overwritten is maybe the wrong bytes are getting overwritten.
Right.
So it's not mattering. The leading 32 bytes of the first dynamically encoded value in the tuple gets zeroed. All right. Let's try this. Okay, here's 15 deploy test. But then we do it with 32 bytes. 32 bytes. 256. 32 bytes. We do it this way, and this crashes. That's weird. 31 bytes.
Or 33.
There's no bytes 32. 40 bytes 31, bytes 31, bytes 31, 2. Can't go from 240. Oh, that's 8. 248. Okay, 31. Okay, we've got 31 bytes. Okay. Now, what if this is a thing that's longer than 1 byte? So 257. That's weird. So we shoved a 2-byte value in here. We used a 31 byte width. And, okay. Oh, it says specifically, the last component of the tuple is a potentially nested, statically sized call data array with the most base type being either uint or bytes 32. And uint is uint 256. The code is using ABI coder. And then there's some type, well, what's this external function thing? So, okay, what if, it doesn't have to do with the inputs. It has to do with the outputs. So it doesn't matter what the input is. The input could be bytes, maybe this is cheating, but Dan, and then call data with a 42 in here. So it's the ABI coder of the output, not the input, I think. So it returns, what's wrong here? Okay, so there's a call data issue. So something's got to be in the call data. Is both of it from the call data? The last component of the tuple is a potentially nested statically sized call data array. Okay, so this one's call data. Call data has to come from the input. But maybe this part can be bytes memory. Can I do that? Can I do bytes Dan? Why not? Can't even read the damn message. So I'm changing the return type here to memory for the Dan part. Deploy on 15, crash. Deploy on 16, pass. Okay, so this is better. Let's go one more step before we save this because we have an unused variable. So we're not using the B here. We're not using the memory. I guess we are using the output there. So now we've got a smaller one because we're not passing the input into the function. We've got a literal here. So the issue here is this word call data here, the word bytes 32 here, these square brackets, and then these parentheses on the output. The fact that it's returning two things.
Another way to minify, does there need to be any input at all?
It wants to have this call data. So it's going to return something with call data. It means the call data is, oh my God, there's 1,000. They're eating my, oh, there goes my grass seed. I didn't know there were this many birds in my neighborhood. Okay, so the call data on the input is what's coming through the output. Is there any way to get call data without using a function input? Maybe. Something dot get call data. Message dot data. Here we go. All right, DT. So what if we can get, maybe. So instead of having the function input be the call data, can I convert a bytes to a bytes 32? I don't know, let's try. Not allowed from bytes 1 memory to bytes 32 memory. Okay. You can't slice into a static array. So it looks like message.data is not going to give us the first 4 bytes of the call data. Okay, message.sig. The type bytes 32 on memory is not convertible to the bytes 32 on. Yeah, okay. All right, maybe that's fair. I can't convert from a literal call data to an array call data. All right, maybe that's fair. All right, I'm not seeing much here where I can get call data if not from the function input. I'm not seeing it. So let's go back a step. This might be the minimal test case. We've done good here. So here's their code with all that, and then here's our code. Way less code. Let's see if we can go brag about this.
Why didn't the Ethereum Foundation security people we just did?
Probably the report came in, was a good enough story to go with.
Right.
Can I credit this? DT, can we credit you on part of this?
Yeah, for sure.
Cool. Close that file. Close this file. So now going to Dan's question, can we just search the whole internet and try to find this bug.
Right.
There's a specific place we can look. We're looking for something where there's some type of a tuple having some type of statically sized call data array, okay? Oh, and it's going to call an external function. Can anybody think of something that has a lot of inputs?
Batch transfers?
Batch transfer. Did you cheat?
No.
What's the only thing worth transferring? NFTs, that's right. Let's look at Seaport. Seaport is the brand new project that OpenSea runs on. So if we can hack Seaport, the bug bounty here is 3 million. Can we regex this and find anything that is going to violate this? Well, yeah, we can regex. We can't find everything, but I'll give you some tricks here that we can get through this. If you use GitHub and you want to, like if you're looking at GitHub and you want to do a nice search, you just hit dot, period. And it opens it up in VS Code on the web using GitHub Dev. This is really nice, but this is not what I want right now because it doesn't have all my extensions loaded. I'm going to open up this locally. And so we got my nice dev environment here. See, this is why I have 2 monitors. I can just put this over here. This works for console. Seaport contains test files, but I'm not sure if they will run or whatever. Okay, so the first thing we want to look for is functions. So we're looking for something in Solidity. Some type of function that calls a function. We're not doing replace, and we're searching inside something.sol. Okay, a lot of results here. 1,200 results. Let's narrow that down. We don't need anything .t. That's a test file. So .t.sol. We don't need that. And then we don't need anything test/, so we can, okay. Is there anything else we can script? We don't need script. So we got 660 things to look through. We're also looking for something with a dynamic sized array. So there's got to be something with a struct containing a dynamic array. Well, there's only 2 kinds of dynamic arrays. One of them is bytes, one of them is string, and then one of them is dynamic, is something with a open and closed square bracket like that. So I don't think there's a lot of strings. Dynamic, what the heck? I don't think there's a lot of dynamic strings here. Error string, we don't care about error messages. Error string. Information is an external view. Nothing we're going to hack with a view. So we're just like, we're viewing every one of these, so it's going pretty quick. Information, external view, okay. Error message, we don't care about errors. Errors, no. Information, name. Hacking a name doesn't help anybody. Name hash. Why are we hashing names? Is this a test? No. Okay. Type hash. Oh, here's that ABI encode pack that they were talking about. They said is a way that you can get hacked. So that would be, that was back on their blog post. They said the ways you get hacked is if you return a tuple, if you call an external function with a tuple, or if you use ABI encoding, if you manually call the ABI encoder. So that's cool, but that's not what we're looking for right now. Okay, we're encoding stuff. Here's an array. Offer item, okay, but there's no, well, I'm gonna flag it, a flag there. Here's something that's dynamic, so string. Okay, so we addressed all the strings. The next one is bytes. So is there something with bytes? This is an interface. We don't need to review interfaces. There's nothing in interface. Okay, returns a bytes. We know that that's not vulnerable. So there's quite a few bytes here. Let's nail this down with a next. It's like with not a word. Is that a B? All right, so there's not a lot of these to look at. We can look at these. Bytes memory. That's accumulator. I don't know what's going on with that, but we'll check. This is the encoding we looked at before. These are just constants named bytes. Orders have bytes. Advanced orders have bytes. So we're getting a bunch of bytes. There's a lot of these. Okay, so maybe I'm trying to narrow down quickly. It's going to match 3. This is an and. So there's 3 things got to match. But we want to narrow it down. Okay, so it looks like using bytes is not going to narrow this down. Maybe we can narrow this down a different way. We can narrow this down. So we're looking for a byte, we're looking for a dynamic array, a static array, and a function call, or some type of ABI coding. So maybe the ABI coding is a way that we can narrow this down. Did they say, does it matter if it's packed or not? Does that matter? With these. ABI.encode family. Okay, so ABI.encode anything. This function could return the wrong value if the last component is static, and then there's a dynamic. Okay. So is this static? This is a byte 32. So this is an immutable byte 32. Bytes 32. Okay, so that's not vulnerable. Next, likewise, this is commented. Likewise, so the last parameter here is not, well, let's just mouse over it. Bytes 32. Okay, that's not a problem. Address, This is not a problem. So this is actually just a string. So there's no problem here. This is just a literal string. Zone hash is a bytes 32, no problem. Resolvers. There's actually a real potential problem because this looks like some criteria resolver that may have a static something in there. So this says the last component of the tuple is a potentially nested static size call data array. Okay, that's a really good one. This one's okay. Zone creation code is just code. This one's got a bunch of stuff, and the last one's a counter. Not really anything. Recipient hashes. Doesn't look like looks like a single array. Amount hashes address text string. Doesn't sound like a static type. Leaf. What is a leaf? Okay. Proof computed hash. End amount. Counter. Order hash. Amount. Okay, so we've found one good candidate here. So here's a potential problem. ABI encode with selector. Okay, so our approach is find all ABI dot encode. Find all external calls. Done. So those are all the ways that there could be problems. A different way to search it is to search find strings, find bytes, find these things. And then we also have, so these are the API code. This is the dynamic. And then we have the static. And we found this one that's a candidate. This could be a problem. So this is an array. This is a type, criteria resolver. Does the criteria resolver meet the condition that the last component of the tuple, potentially nested, is a static size call data array? The criteria resolvers, are they in the call data? Oh, memory. So that's really close. So here the criteria resolver is specified as a memory type, and this is not a call data type. This was close because it was the last item in the array, and and the last type was even a bytes 32, which was the magic type, but it was dynamic. So we were getting pretty close here to a problem. So it was a memory type, bytes 32, and it was not static. So this one did not get attacked. All right, so we're gonna turn that one off. But that was, getting close. Assert restricted advanced order validity. Now, something you want to do too is when you find something that's pretty darn close, what you want to do is you want to click here, and there's something that is like real similar, like right next to it, like right next to that in the same file. Maybe they did it differently. So assert restricted advanced order facility. Okay, so basically I want to look for anything else in this file that has a criteria resolver. And probably it's going to be a function indented this way, so I can do it like this. There's only one. Okay, let's check the whole file real fast. Is there any other... So I'm just looking for any other functions that have criteria resolvers in there that are call data. Like, look, this one uses call data. So this is, getting close. Oh, this one has a return. Call data resolver, maximum fulfilled. So, like, these are returning tuples. This one's returning a tuple. Bool memory, this is dynamic. And then executions, that's also dynamic, so that's not eligible. Returns executions, that's dynamic, memory, ineligible, memory, boo, memory, call data, okay. Returns executions, that's dynamic. Call data, good, nothing, okay. Call data, okay. Call data resolvers, fulfillments. This is not an API coding because, oh wait, yeah it is. Zone.execute matched advanced orders. Fulfillments, okay, that's dynamic. So this is pretty close. I mean, this is doing an external function call with the criteria resolver. It's using the API coder. It is a call data. It is a dynamic array. The last element also has an array, but the last element is not, well, let's look at this. Fulfillment, okay, let's tag this because the last element needs to be bytes 32. Static. Let's go find fulfillment. Let's go find how. Snap. So when you're getting deep into these things, you got to learn this button right here. It saves your search results because I want to lose those. And then because I want to search for something else real quick, fulfillment. So I want to get this struct. Yep, here it is. Ooh, and the last element of fulfillment is an array, but it is dynamic. We're getting super close here. Like we're getting like 4 out of 5 conditions here to have a serious problem. 5 out of 5, that's $3 million. So, we're gonna look through these. Yes, we are live streaming alpha, $3 million. Like you go faster than me, you're gonna steal the 3 million, right? That's what it takes. That's what we give you here on this call. We went through all the ABI encodes, so this is done. We could go through all the external calls. Another approach is that we can look for static arrays, because that has to be the last component. Something with a square bracket open. There's a lot of those. A number.
Actual numbers in between.
It's not going to be a 0 because we know that you can't make an empty static array. We tried that. We reported that bug. Populate the order as the first and only element. So they're using advanced, they're even making, this is a memory type. Okay. They're even doing it as a dynamic array, even though they're only putting a static thing in it. Okay, that's weird. Retrieve the order parameter after applying function resolvers. Why are they using the first one? I don't know, but this is a array access, not interesting. Valid offsets. Okay, we're using some weird call data decoding. Here's a R value, R value, R value. Bytes 1, bytes 32, 1. So that is that's a type. That is a statically allocated type, but it's a memory type. So we found something. Not a lot left here. Consideration component 0, that's the first one. The first one, signature, and that's loading. All right, so we found nothing. So the one leg that was supporting us, which was we needed to find a statically allocated array as the last element of an ABI encoding, we failed to do that. So we know that that's not the case because we checked any type of statically allocated array because we looked for anything with a square bracket and then a number. All right, I think we've successfully reviewed this and not found any of these things, so we don't need to check further. And that's it. This is an important finding. So let's go back and find my alarmist tweet from yesterday. Here, this online today. Find a statically allocated array type from call data. And you gotta put arrows in your screenshots. Here, anything dangerous in here? No. Okay, tweet. So I think it was fair to put out that tweet yesterday, saying beware, this is dangerous. And we got pretty darn close to finding something. So there's one last thing I want to check, which is the original, the old OpenSea protocol, the Wyvern contract. Still a lot of transactions. This is not an affected version, 0426. So this started with 05. Just want to see if there's any other marketplaces we should check real fast while we're here. Rarible marketplace. I'm looking for a marketplace because a marketplace is where you would be calling a function and then having tuples and passing a lot of stuff with big arrays. Zora, Foundation. This looks like something I made. Ownable delegate proxy. Zora auction house. 0.6.8 ABI encoder v2. Okay, that's already meeting the requirements. It's greater than 0.5. We've got auction house, a bunch of other common stuff, market interfaces, address, decimal, math. All right, so not a lot here to look at. Looking for any function here, and there's only a couple that has some type of call data. So you just look for the word. Did they have the word call data back then? Looking for some type of an array here. Nothing. Create auction. There's nothing. It's not going to call anything. Transfer from. There's nothing dangerous there. Set approval. Create bid. Auction amount. Yeah, there's nothing fancy there. End auction. Cancel auction. Incoming. Outgoing. Private. Okay, so they're done. Audit complete. Nothing found on Zora. Foundation market. It's another big one. Got some.
Also, Nifty Gateway. Super rare.
So this is 0.6, but it's not v2. Nifty Gateway. If you have a website and you have a DApp, you should put the address right on the bottom under About Us.
No, that'd be too obvious.
Yeah, it'd be too easy. See, I'm trying to help you, and you're not even letting me help you. All right, screw Nifty Gateway. What's next? We tried.
Super rare.
Super rare. 0.4.22, not affected. Next.
The NBA Top Shot.
We need something that's going to call into other smart contracts, so it has to be some type of marketplace.
Okay.
So here's something listed here.
Quint. Quint.
Quint Marketplace? Okay.
Yeah. Oh, Binance has their NFT marketplace.
Cool.
Crypto.com.
Binance NFT Marketplace. So I'm really having trouble finding all these contracts that are not extremely popular because I can't find them on Etherscan. I can't find a transaction that they made to find where their contract is. And, that's your problem. So if you want me to audit your contract, hit me up. Otherwise, I'm not going to spend all day literally looking for you. But we did go through OpenSea.
Foundation call.
This one's got a bunch of stuff an hour ago. Yeah, this was, we looked up Foundation.
Oh, we
Yeah.
did that already?
First of all, it's using the affected version of Solidity, but it's not using ABI version 2. Not affected. Mintable. Decentraland, 0.4.11, not affected. Another fun approach is we can use top accounts by transactions. I wanted to find top smart contracts. Top transaction count received. Okay, I think does Uniswap call external stuff? Yes. It calls the external transfer function. Does the external transfer function that it calls have a static element at the end? Probably not. So Uniswap is probably not affected. Coinbase miscellaneous. Yeah, that sounds good. And it's just a account that just collects money. Okay. Centra USD coin. Okay. Wrapped Ether, WETH. Does WETH call other contracts? No. Uniswap V2 probably only just affects ERC20s and just 20s. Whatever the heck this is that doesn't have a name, but it's a top 10. ENS. Well, ENS is complicated. There's a lot going on with ENS. Does ENS have return a tuple? Probably.
What about Chainlink?
That's a good idea. They do it. They call external functions.
Right, and there's lots of, if there's a function where you want to look up your sources, you have to return an array of the different sources for a piece of data.
Chainlink. Yeah, I want to find the actual contract that is doing the Oracle stuff. What would be cool to have is, so I actually have a copy of all the smart contracts saved, all the source code, but it's not super helpful to use. So I can just grep that. But going through one contract was hard enough, so going through a whole bunch of them is not any easier. Now you can do pretty good stuff with regex, but you're going through every contract that was ever deployed, all the smart contract source code ever.
Right.
What would be helpful if I just had the smart contracts that mattered, like the ones with money in them or transactions or that own that would be a nice list to compile.
Well, I'm sure it's probably some Dune or Nansen dashboard or one way to build.
Yeah. I mean, that's something I would buy. I would buy that data set. I would buy a list of useful addresses, because that would be a subscription. I'd update it and then I'd use it for stuff. Most of this call we spent searching for people that we want to help, but it's fine. That's what you do. We're trying to help Solidity project. We found it. It clicked. We gave them an issue. This has been great. This is what it looks like when you find something that's a bug. You want to exploit it. You want to find out, what's vulnerable. We're doing this publicly, which may or may not be best practice. But again, we spent how many hours on this of our free time trying to help people and got 4 out of 5 close to finding something super big. But we don't have all day. If we didn't do this publicly, it would have gone slower. Doing this together made it faster for me. Dan was a help. We had some other comments here that were a help. That moves faster. You might say, oh, well, best practice is you should do security research privately. You shouldn't live stream hacking billion-dollar marketplaces. And I think you should live stream hacking billion-dollar marketplaces because it's easier. And, until they pay me to do this privately, this is what I'm going to do. I'm going to do whatever's easiest for me, right? This is my time too. I think it was valuable here to go through this, and we'll slice this up for the YouTube video version, but this is the process. This is exactly what you do. This is what it's like. It's live. We did this before. We've done other 0 days here. Live 0 days announced on live stream, day 0. So that's been cool too. We did that with actually GitHub pages. This is how security research is done. So thanks everyone for participating. It's slow, it's steady. The other one was like 5 hours. And we had 10 people because we were going through a list of like 200 candidate websites that were vulnerable to try to tell them. And we did it with 10 people over like 5 hours. And that was a lot of work. People appreciated it. GitHub fixed it. I appreciate GitHub, so I'm happy to help.